Welcome back, everyone. We're going to continue our discussion of graphing parabolas by taking a look at situations where the vertex is not located at the origin. So the same notes we were working on before, continuing on with problem number 3. So if I look at problem number 3, which is already put into standard form for me, I notice a few things. First of all, the x term is squared and p is greater than 0, so this parabola opens up. I also notice the coordinates of the vertex are -3, +4, and 4 times p is equal to 8, which tells me p is equal to 2. And from there we can graph the parabola. So I'm going to first start out by graphing the point at -3, +4. 1, 2, 3, 1, 2, 3, 4. And I know that the parabola opens up, so my directrix is going to be below the vertex, and it's going to be 2 units below it. So I'm going to draw my directrix in there, and all directrix are lines, and all lines have equations, and the equation of this directrix would be y is equal to 2. I also know that my focal point is going to be above my vertex, 2 units in this case, so I'm going to graph my focal point. And I know that the focal width, 4 times the absolute value of p, is equal to 8. So from my focal point, I go 4 units in each direction, and 1, 2, 3, 4, 1, 2, 3, 4, and now I can accurately graph my parabola. I guess the one thing that I neglected here is to write down the coordinates of the focus. So the coordinates of the focus are going to be -3, +6. So let's take a look at number 4. Again, the x term is squared, and in this case p is less than 0, so we know that it opens down. We also know the coordinates of the vertex are +1, -2. 4 times p is equal to -8, which means p is equal to -2. And so we can start to graph this thing. So let's first locate the vertex, +1, -2. We know that this thing opens down, and therefore the directrix is 2 units above the vertex, so the directrix is going to be right here on the x-axis, which is going to have an equation y is equal to 0. The focus is going to be 2 units below the vertex, so that's going to be right there. So the coordinates of the focus are 1, -4, and the focal width, 4 times the absolute value of p, is equal to +8. So we go 4 units in each direction from the focus. 1, 2, 3, 4. 1, 2, 3, 4. And we can accurately draw our parabola that opens down. All right, so we're going to do a few more problems like this, and then we're going to move on and take a couple of parabolas in general form and put them into standard form. So when I take a look at number 5, here's what I see. I see that the y term is squared and p is less than 0. So I notice that this opens in a negative direction, or in this case, I also notice that the vertex has coordinates 2, -2, and the value of 4p is equal to -12, which means that p is equal to -3. So we're going to draw some of this, and then we're going to write down the rest of the information. So I would go to the vertex at 2, -2, plot a point. I know this opens to the left, so I move 3 units to the right from there. 1, 2, 3, and I draw my directrix, and therefore the equation of that directrix would be x is equal to 5. I go back to the vertex, I move 3 units to the left, 1, 2, 3, and I've got my focus. So the coordinates of my focus are -1, -2, and the focal width, 4 times the absolute value of p, is equal to 12. So I go to the focus, I go up 6 units, and I go down 6 units, and I sketch my parabola. Fairly straightforward. All right, take a look at one more problem, and then we'll move on to completing the square. So in problem number 6, I notice that the y term is squared and p is greater than 0, so this opens in a positive direction and it opens right. I also notice that the coordinates of the vertex are -1, +3, and 4 times p is equal to 2, which means that p is equal to 1/2. All right, so let's graph the vertex, -1, +3. Let's move a half unit to the left to draw the directrix. And the equation of that directrix, therefore, would be x is equal to -3/2, or -1.5 if you prefer. And we will move a half unit to the right. This is really tight in there. The focus has coordinates, we'll call it f, at -1/2, +3, and 4 times the absolute value of p is equal to 2. So the focal width, the width of the parabola at the focus, is 2 units. So from the focus we go up 1 unit and down 1 unit, and again very, very tight in there. So that's what our parabola looks like. Alright, so at this point what we're going to do is we are going to take the equations of a couple of parabolas that are not written in standard form, and we're going to put them into standard form. So let me get to the correct page here. So this is problem 7 and 8 in your notes. So let's go ahead and get started with this. So what we need to do is we need to get this into a form where we can readily tell the coordinates of the vertex and the value of p. So I noticed that the x term is squared in problem number 7. So what we're going to have to do is complete the square for the x terms. And to start out with, I am going to add 4 to both sides. So the left-hand side is going to become y plus 4. And the right-hand side is 1/4 x squared plus 1x. You cannot complete the square, as you recall, on the right-hand side until the leading coefficient is 1. So we're going to have to divide all the terms on the right-hand side by 1/4. We're going to do that as a factoring problem. So we're going to factor out a 1/4, the x squared term there, plus, this gets a little bit tricky here, figuring out what term goes in front of the x, but the easiest way to do that is to think about when you multiply the 1/4 back in, you need to end up with 1 in front of the x. So that would put a 4 there. So now we can complete the square for what's inside the parentheses. So it's going to go like this. Y plus 4 is equal to 1/4 times x squared plus 4x plus half of the x term squared. So half of 4 is 2. Square that, you get a 4 here. And what we end up with is the following. 1/4 times x plus 2 quantity squared. Now, we added this 4 to the right-hand side of the equation, so we have to adjust on the left-hand side, but we were also going to multiply that by 1/4. So 1/4 times the 4 is equal to 1, so we're just going to add 1 to the left-hand side, so we'll end up with y plus 5. Now, we're almost in the standard form here, except The 4p is not what gets multiplied by the term that's squared. The 4p gets multiplied by the term that's not squared. So we need to get rid of the 1/4 in front of the x plus 2 quantity squared. So we're going to multiply both sides by 4. So if we multiply the left side by 4, we get that. We multiply the right side by 4. These cancel. And now we have 4 times y plus 5 is equal to x plus 2 quantity squared. And it is now in standard form. And we can tell a lot from there. For example, we see that p is greater than 0 and x term is squared. So we know that this opens up. We know that the vertex has coordinates -2, -5. We know that the value of 4p is equal to 4, so p is equal to 1. And we can go down here and start graphing this thing and figure out everything else we need, like the coordinates of the focal point. So let's go to the point -2, -5. -2, -5. 1, 2, 1, 2, 3, 4, 5. That's the vertex. We know that this opens up, and we know the value of p is equal to 1, so the directrix is 1 unit below that. The equation of the directrix is going to be y is equal to -6. The focus is going to be 1 unit above that, so the coordinates of the focus are going to be -2, -4. And the focal width, 4 times the absolute value of p, is equal to 4. So we go up to the focus and we go 2 units in each direction, and we have, 2 units in each direction, and we have those points on the parabola, and we can accurately draw our parabola like that. Okay, last one. Similar problem, except we're now going to complete the square in terms of y. So you can see that the y term is squared, so that's what we're going to complete the square with. There's no constant on the right-hand side of this equation, so we don't have to move that. What we're going to do is we're going to write this as x is equal to 1/8 times y squared minus 8y, because 1/8 times -8 is going to give us the -1 that we have in the original equation. Half of -8 is -4. If we square that, we get 16. So on the right-hand side, we have 1/8 times y minus 4 quantity squared. On the left-hand side, we have x, but we added this 16 on the right-hand side, and it is being multiplied by 1/8. 1/8 times 16 is 2. So effectively, we've added 2 to the right-hand side, so we're going to add 2 to the left-hand side. We'll put parentheses around that x plus 2. And the 4p always gets multiplied by the term that is not squared. So to get this into standard form, we're going to multiply both sides by 8. And the 8 and the 1/8 cancel, and we've got this in standard form. 8 times x plus quantity x plus 2 is equal to y minus 4 quantity squared. So we can see that the y term is squared and p is greater than 0, so this opens to the right. The vertex are -2, +4. We can also see that 4p is equal to 8, which means that p is equal to 2. So we're going to go down here and plot our vertex at -2, +4, -2, +4. We know it opens to the right, so we have to go 2 units to the left of that to graph our directrix. And the equation of our directrix will be x is equal to -4. Go to the right to draw our focus. So the coordinates of our focus are going to be +4. And our focal width, 4 times the absolute value of p, equal to 8. So from our focus we go up 4, 1, 2, 3, 4, and down 4, and then we can accurately parabola. So we will stop there for now.